About to go through this solubility curve worksheet. We're going to start with number one. Number one says list all of the solutes found on the solubility curve. So if you look at the solubility curve, you'll see sodium nitrate, NaNO3, CaCl2, PbNO3, KNO3, KCl, all of these things on the lines. All right, if you see all of them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. All 9 of those things are solutes. Every single one of them is a different solute. All right, so you would list all of those out. Number 2, it says, what is the solvent? If you remember when we talked about solvent, if you look on the left side on the y-axis where it says solubility, grams of salt in 100 grams of water. The 100 grams of water, that is your solvent. That is what we're putting all of the solutes into. All right, number 3. Number 3 says how much solvent, volume means how much space it takes up, is there? Hint, use the density of H2O. The density of H2O, density of water is 1.0 grams per mil. So if we have 100 grams of our solvent, 100 grams of water, and there's 1 gram per 1 mil, then there's 100 grams, there's 100 mils. So there's 100 milliliters of our solvent as well as 100 grams. You say it either way, it means the same thing, right? It's like I weigh 300 pounds or like 137 kilograms. It means the same thing pretty much. All right, number 4. Which solubility is affected the most by temperature? So in math, you're taught about slope, right? Rise over run. So you're looking at how steep. Which one is the steepest when we increase temperature? Right off the bat, CaCl2 and KNO3, the oranges and the green lines jump right out at me. Now looking at the line, all right, you got to think about which one is increasing the most. Which one solute is increasing the most as we increase temperature? I think I would say I'd go with CaCl2, calcium chloride. I think it's increasing a little faster than KNO3. What number are we on? 5. Number 5, which solute solubility is affected the least by temperature? So here we're looking for a line that does not change very much as we increase temperature. So if you look at the NaCl light blue line, it starts off at about 33 grams, and you can increase the temperature all the way to 100, and it only gains like 6 or 7 grams of solubility. So it doesn't move up very much as you increase the temperature. So NaCl, sodium chloride, is affected the least by changing temperature. Number 6, list all the solutes whose solubility decrease if you increase the temperature. So we're looking for like the opposite of going up, right? The slope going down as we increase temperature. There's only one that I see. Which one is that, Josh? Ah, boy, Ce2SO4 3. You're gonna be on my YouTube video, Josh. You're gonna be famous, right? That's the only one that decreases as temperature increases. Number 7. What solute is the most soluble at 0 degrees? So I'm gonna go look at 0 degrees on the x-axis, and I'm gonna go all the way up to the most soluble one, which is the highest one up on the graph, is NaNO3. That's the most soluble. So now if I'm doing the same thing at 0 degrees for number 8, but I want to know which one is the least soluble. Which one's least soluble, Isaiah? KClO3, right? KClO3. Good job. Good job. All right, so that kind of does that section there. Let's scroll down to number 9. All right, so here, 9 through 15, we're going to say it's unsaturated, supersaturated, or what? Saturated. I don't remember what I said, what order I said them. All right, so number 9. Number 9 says 56 grams of, that's a typo, right? That should say PB. PbNO3 too. All right, 20 degrees Celsius in 100 grams of water. So we're going to go to 20 degrees Celsius on our graph. We're going to go up to 56 grams, which is slightly over halfway, and that hits dead on the PbNO3 line. If it hits dead on that line, what's it mean? Yes, saturated, right? Saturated, good job. All right, so those are easy, right? Number 10, 82 grams potassium nitrate, 50 degrees Celsius. So we're going to go 50 degrees Celsius. We're going to go up to 82 grams. About right there. All right, we're going to compare this to the KNO3 line, the green line. All right, what's our answer going to be? Is it on that line? No. Is it above the line or below it? It's below it. Okay, so that means it's going to be unsaturated. Unsaturated. All right, it was close to it, but it was still slightly under it. Number 11, 60 grams of KCl, or just KCl, at 100 degrees Celsius. So I'm going to go to 100 degrees Celsius. I'm going to go up to 60 grams. Okay, what kind of solution we got here? Supersaturated. Yeah, good job. Good job. It's above that line. We are at what? What number are we on? 12. 40 grams of sodium chloride at 95 degrees Celsius. So I'm going to go here to 95 degrees Celsius. I'm going to go up to 45 grams. Looking at this NaCl line, does it hit that line? Yes, it does. So that gives us a saturated solution. Is this weird? Like me videoing this in front of y'all? Go through it. I like it. I think it's pretty cool. Good vibes, right? Good vibes. 13. Talking about cesium sulfate, Ce2SO4, 9.5 grams at 9.5 degrees Celsius. Ariana, what you think about this one? Super saturated. It hits a line, don't it? Right? But is that the Ce2SO4 line? Is it? It is, right? So that's going to give us a what? Saturated line. I looked at the wrong line too. At first, did you look at the wrong line? I did. I was like, yeah, that's super saturated. But no, it does hit the Ce2SO4 line at 9.5, 9.5. All right. 14. 80 grams of lead nitrate. So we're going to go to 45 degrees Celsius. We're going to go up to 80 grams. So 45 degrees Celsius is right between 40 and 50, right? So we're going to go to 45 degrees Celsius. We're going to go up to 80 grams. What do y'all think? Yeah, I think it's too close to call. I'm going to say it hits that line. It's going to be saturated. Let me erase that. Uh-oh. My thing just disappeared. My graph. All right, we're back. All right, what are we at? 14, 15? 100 grams at 45 degrees Celsius. So we'll go to 45 degrees Celsius. We're going to go up to 100 grams. Now, when we compare that to the NaNO3 line, unsaturated. Now, at 100 degrees, you can see where that line is clearly to the left. So it's not going to be on that line. If you kind of extend that line further, you'll see it's going to fall below that line, and it's unsaturated. All right, moving on to the last part. These are going to be some of the more challenging ones. Number 16, which compounds have the same solubility at approximately 12 degrees? So I look at 12 degrees on the graph. I'm going to go up until I find two salts that have the same solubility. Which two salts are those going to be? Anybody see those? Where does two lines cross at 12 degrees? Oh boy. Well, Ce2SO4 and what? The K2Cr2O7, right? Those two lines cross at 12 degrees, right? They cross over each other. They overlap. So at that moment, they both have the same solubility of like 9 grams or whatever. All right. Let's look at the number 17. Which compounds have the same solubility at 71 degrees Celsius? So I'm going to do kind of the same thing. I'm going to go just past 70 degrees at 71. I'm going to look for two lines that overlap each other. Do we see two? KCl and K2Cr2O7. That's potassium chromate or potassium dichromate, something like that. So when they overlap, that means at that exact moment, if you're making those solutions, those salts, you put the exact same amount in to make a saturated solution. Number 18, how much KClO3 is needed to form a saturated solution into 200 grams of water? So I look at KClO3. What's my temperature here? 30 degrees Celsius. All right, so at 30 degrees Celsius for KClO3, on this graph, right, a saturated solution is 70 grams, right? So if this question asks us how much KClO3 is needed to make a saturated solution in 100 grams of water, because our solvent on this graph is 100 grams, then our answer would be 70 grams. But it doesn't ask that. It asks us how much can go into 200. What's up, JT? It'd absolutely be 140 grams. All right, so we need to double our solvent found on this graph here, and that'll give us our answer. Good job. All right, let's look at 19. 19 is going to be very similar to that. 19 says how much NaNO3, sodium nitrate, is in saturated solution with 50 grams of water at 10 degrees Celsius. So on our graph at 10 degrees Celsius, if we look at NaNO3, which is this line way up here, right, we need 80 grams. All right, we need 80 grams. But that's in 100 grams of water. We want to know how much do we need in 40. Yep, 50 grams of water is half of 100. So we need half of 80, which is 40, right? So we can kind of set it up as a proportion. We can do, this graph tells us we can put 80 in 100, all right, but we need to know how much goes in 50. So you can set that proportion up, right, and you will see your answer should be 40 if you work that out, all that good stuff. All right, so let me erase this off my curve. We're on 20, right? Number 20. All right, 20 says, a saturated solution of KCl at 75 degrees Celsius contains roughly 50 grams of KCl. So on my graph at 70 degrees Celsius is telling us, right, that KCl contains roughly 50 grams. Right, so we're just going to use 50 grams for KCl there. How much will precipitate out of the solution if it's cooled off to roughly 43 grams? All right, if we cool KCl off to roughly, or 43 degrees, 43 degrees, right? The solubility at 43 degrees is 40 grams. So we're dropping from a temperature that can hold 50 grams down to a temperature that can only hold 40. So how much will precipitate out? 10 grams, because we're 10 grams over the solubility. Now it might stay in there, might not, just depends on how it goes. Eventually it would precipitate out some way or another. Okay, let's look at 21. 21 says I have 90 grams of KClO3, potassium chloride. How much solvent is needed to make a saturated solution 70 degrees Celsius? This one's a little weird. So at 70 degrees Celsius, on our graph, a saturated solution is 30 grams. Right? In the question, it says that we have 90 grams. So we are 60 grams over, right? Our solvent for this graph is 100 grams. How much more solvent would I need to make this saturated? Yeah. If I added 100, that would give me 30 more grams, right? So now if I add 100, right, that would double this graph. Now my solubility would be 60 grams in the saturated solution, but I have 90. So I'm going to need a total of 300 grams so that this 90 grams becomes saturated. That's kind of weird, right? And the whole key to this one is just remembering this graph is based on 100 grams of solvent. And 100 grams of solvent, 30 grams of KClO3 is saturated. So you can set this up proportional if you want to. So we know that in 100 grams of water, I can put 30 grams of solute in it. I want to know, or I have 90 grams of solute.